And joining us now in New York, New York, Stephon Alexander, theoretical physicist and jazz musician, joining the faculty of Dartmouth College in Hanover, New Hampshire in the summer. And Stephon, we're very happy to have you on TVO tonight. How are you doing?
I'm doing great. I'm doing great. You know, there's a little bit of traffic down here in New York, but otherwise,
I hear
it's
it is
Friday,
always
so.
thus. Yes, indeed. I want to start because we're sort of exploring this notion of creativity on our program today. I want to get your definition of creativity and see if it differs from our previous guests. So how would you define it?
Well, I mean, a big part of creativity, for me at least, is that it's undefinable. But the parts of creativity that I can try to define has to do with novelty. You know, there are many domains through which one can be creative. You know, I'm a student of jazz. I play out. I'm also a physicist. So in both domains, you know, I get the opportunity to exercise creativity. And usually, let's just talk about physics. There's usually a problem, some insoluble problem, a research problem that one is working on, or, you know, students might try to solve problem sets. And normally, creativity usually involves finding maybe a novel solution. You know, usually there's a word of, you know, the aha moment, a moment of insight that you really can't define, but it allows you to basically make a leap, like a quantum leap, for lack of a better word, in solving a problem. But of course, in music, it's usually one is not solving a problem, one is trying to make a beautiful melody or, you know, play some good music. And in that domain, I would say that creativity involves coming up with a novel way of, you know, connecting notes, you know, that make the music sound beautiful.
Well, let me do a follow-up on that, if I can,
yeah.
Stephon, because
Yeah.
I totally get what creativity looks like when you are playing your saxophone. There's no mystery there for me.
Yes.
I don't know what creativity looks like when you're doing your thing as a physicist. So follow up on that if you would. What does that look like?
Well, I mean, what it looks like is usually years and years of you know, of learning the craft. You know, so behind, I think, a lot of that. So if I'm working on a new research problem, like, first of all, you know, as we know, physics is a very broad field, and I'm a theoretical physicist, and you know, in the experimental domain of doing physics, there might be some differences. But speaking as a theoretical physicist, you know, our lab is our mind, and other people's minds, of course, because we collaborate a lot. So in that process, in the process where creativity may show up, of maybe trying to solve a research problem, you know, there's usually a lot of what I call hard work, or, you know, grunt work that's involved in trying to solve a problem that happens years before. And so one is, you know, one has a toolbox of trying, you know, that one could resort to. In this case, it's mathematics, or the ability to come up with diagrammatic ways of representing a physical problem. I mean, a lot of the research I do involves, you know, understanding phenomena that's not on planet Earth. So you know, I can't go out to, you know, I can't go out to some distant galaxy. So I have to imagine being there. So I have to, sort of, in a sense, place myself in that world. And it's very similar to, you know, maybe a comic book writer, someone that's, you know, designing a superhero. So, and in doing that, I think that exercise of, pardon me, that exercise of placing yourself in a situation that you've never been in before, in this case, some distant galaxy, it allows your imagination, well, it doesn't allow, it challenges, in a sense, your imagination to, you know, at some point, you know, you just have to give in to the problem. And that's, I think, this tension or combination of having a toolkit, in this case, your mathematics, you know, an arsenal of problems that you've already solved and understood in the past, and this new situation that you're imagining. There is, I'm lacking a word here, but there's a tension between letting yourself go, suppressing this imagination, being able to basically come up with the wildest and the craziest thoughts, and allowing yourself to actually do that. And that's usually the moment where I find my creativity comes out the most in solving physics problems.
Well, let me follow up on that if I can.
Yeah,
sure.
I'll
jump in with a follow-up, because I understand the kind of creativity that's required to play the saxophone, and I understand the kind of creativity that's required to solve some theoretical physics problem. I would not have thought those were the same kind of creativity, though. Are you telling us tonight that essentially they are?
I'm saying from my personal experience, they're very similar, and in some cases identical. Yes.
Okay.
Yes.
You were going to give an example a second ago when I interrupted you.
Yeah. So, for example, one of the projects I'm working on now is trying to understand the nature of dark energy. The Nobel Prize was given this year for the discovery of dark energy, but we have no understanding in terms of real physics today, as we know it, what this dark energy is or how it comes about. So it's something that's impossible to place yourself into. So this idea of becoming, and in a sense, playing jazz, at some point, there is a sense of becoming the music. I mean, you lose the separation between the player and what's being played when you're really in the moment of playing. Like, I know some people call that word flow, or being in the moment, or a Zen moment. But every now and then, when I tap into that, or I'm playing, because I do improvisational jazz, and I'm really, at one with the notes that I'm playing, that's usually the moment where novelty comes out. And I don't really feel, if I catch myself and say, oh, this is really cool, then I lose it. And that's okay, because sometimes one has, you have to do that.
But I guess there is a similarity there, isn't there, Stephon?
Really cool.
There is a similarity there insofar as when you're just, when you're improvising, playing your saxophone, I guess when you're trying to find the solution to some theoretical physics problem, there's a lot of improvisation that goes on there too. Is that fair to say?
Yes, there is a lot of improvisation. So thanks for bringing that up. There is, when I, just going back to the physics, the creativity in my physics research, I have actually imported some of, I think that there's also a style involved in creativity. So in physics, there are different styles, different ways, different modes of approaching a problem. And it sometimes could be, impacted by culture. The culture one grew up in. So, I'm originally from Trinidad, grew up in New York City, and I think that, being a person of Caribbean ancestry, we have a lot of black magic, for lack of a word, voodoo, and all this folk culture, and creatures lurk in the night, sukunyas and all these types of.
How useful is all that for solving a theoretical physics problem?
Well, sometimes I think it makes one's imagination very elastic.
Okay.
And I'm not afraid to have the craziest ideas and tell my friends the craziest ideas, because I also have a confidence of this arsenal and the toolkit that I know I can refer to. So I allow myself to just go there and take a chance with a crazy idea.
So that
and
opens
if
your
it's wrong,
mind
it's
up.
wrong. I let go of it. It opens my mind up. Yes.
Because we just talked to Jonah Lehrer earlier in the program, and he's got a new book out called Imagine, in which he talks about the best circumstances in which a person can put themselves in order to be truly creative. And one of the things he told us was, sitting there and focusing on a problem and giving it 100% concentration hour after hour after hour is not the best way. Sometimes you've got to go away. Sometimes you've got to take a shower or go for a jog. You've got to get away from the problem to get the creative juices flowing. Do you find that to be the case as well for yourself?
Absolutely, I totally agree with that. I would say, though, for me, I've been an avid cross-country runner over the years, but my Achilles is, in bad shape. But what I found to be nice for me is that I actually, when I'm working on a difficult physics problem and I'm pounding my head against the wall, not literally, I just go and I go to a jam session and I play my sax. And so I find that playing music for me opens my mind up and allows me. I've also like been lucky to actually solve a physics problem in the middle of a solo, for example, and vice versa. And vice versa. My physics, you know, the fact that I do physics and I work on a physics problem, and then I go and I play, not immediately, of course, but maybe a day later. I do find that sometimes, you know, allow me to be more adventurous in my solos, for example.
Okay, I got to follow up on that because I don't quite get that. I understand how playing the sax can help get you away from, you know, theoretical physics and perhaps open your mind up to some possibilities when you go back to your physics world. But how exactly does doing physics open you up to playing a kind of a riff that you might never have done before on the saxophone?
Yes. So my style, and you know, there are all these different styles of playing jazz. I mean, I play, of course, in the the bebop tradition, hard bop tradition, and you know, there's a lot of structure there's structure certainly in a lot of jazz standards, you know, rhythmical harmonic structures, and you know, one has to be creative in how you play within and outside of that structure, and I find that, you know, the visualization exercises that I have to access in solving physics problems, because I'm very visual when I solve problems. I sometimes like to see the problem and have a visual representation of the problem. I find that you know, honing that skill in my physics and doing my physics helps me visualize certain patterns, and instead of referring to like A, B, C, D, E, right? For some reason that I can't explain, I'm able to access you know, certain visualizations of melodic lines or harmonic structures, and I find that to be fun and also challenging, but it sometimes comes more naturally just by working on physics problems.
Well, you say you can't explain it, but I'm going to push you a little further to see if we can get some explanation, because I know people watching want to see if they can recreate those circumstances in order to help themselves. For example, you did a paper on colliding galaxies, and I wonder what sort of predicament or circumstances you put yourself in to allow you to have that eureka moment that enabled you to write this paper with all of these new ideas in it.
Oh, yes. Oh, actually, I do work on galaxies, but I think that one of the papers you're referring to is actually even crazier. It was a paper on colliding universes.
Colliding universes, okay.
Yes, I wrote, yeah, that's right. That was interesting. It's kind of always a little bit embarrassing, so but I'm happy to talk about how that came about. I was a postdoc. My first postdoc was in London at Imperial College, and within a week, I found myself at a 3-month string theory workshop in Paris, and I realized that I was way above my head, and everyone was, you know, so much smarter than I was, and more prepared and all that stuff. And also, I was like one of the few Americans out there at the time, or Canadians actually. It was mostly Europeans out there at the time, and a lot of it was because their background was much more technical at the time than mine, and out of, I guess, you know, it was a 3-month workshop, so within a month I kind of got depressed and just found myself hanging out in the pubs of Paris. And just coming to the conclusion that maybe I should just go back and become a musician and give up on this physics thing. And, but, you know, while hanging out at this pub, I said to myself, you know what, I might as well just go and I might as well just play around with ideas because it's fun. And so I grew up, you know, I used to draw pictures, and at the time I was thinking about inflation, cosmic inflation, this idea that in the early universe, the universe underwent some very rapid expansion, and that led to all the structures that we see today. But we had no real theory of inflation, and in particular, no theory of inflation in terms of a fundamental unified theory, which string theory is one of the strongest candidates for that. So I was sitting there, I'm working on some ideas, and anyway, I gave up. And at some point, there was a TV, and I saw people clapping on this TV, and I just made the association, you know, with the clapping hands, and these objects in string theory called D-branes colliding, and then I started working on the equations, and I found solutions, and that paper got published, and it's my highest cited paper. It has like a little bit over 200 citations now, so I got very lucky. But that was definitely one of my greatest moments of creative insight. So yeah, it was kind of in. A lot of my colleagues would laugh at that, but I find it amusing that
well, and it was
came about that way.
It was the clapping hands that gave you the insight. Is that what you're saying?
Yeah, I just made that association between clapping hands and these solitonic objects in string theory called D-branes, which are high dimensional, and when they collide, and you solve the equations of string theory, it does give you solutions of inflating space-times like ours.
Huh. You know, I've probably interviewed a half a dozen theoretical physicists on this program and asked them to explain string theory to me, which they have a half a dozen times, and I still don't get it. And I'm not going to ask you to do it because I'm still not going to get it. So I'm going to move right along here. I think, Stephon, it's fair to say that most people in the theoretical physics world, if they're good at anything else besides theoretical physics, it's probably something like chess. You know, because people see a consistency between doing physics and chess. They wouldn't see a consistency between doing physics and the sax. They might between physics and a different kind of music, maybe classical music, but not improvisational jazz on the saxophone. Why do you think, I mean, do you have any clue as to why that combination works for you?
Well, I think, I think because I work on modern physics, which involves a lot of quantum mechanics, that the intuition behind quantum mechanics, I think, is very similar to, again, certain styles of my particular style that I'm trying to develop. So a lot of it I'm also trying to develop in jazz. One can develop, you try to develop your own voice at some point. And, and I think improvisation, I like to think about quantum mechanics, for example, not as a theory of uncertainty. Often we hear about, you can't know the position of a particle and its velocity at the same time. They're uncertain, knowing one makes the other one uncertain. But I like to actually think of that as not uncertainty, but a question, it's not a theory of probability, but a theory of possibilities. And I find that improvisation is, again, not a probabilistic process where you're randomly playing something, but it's what's possible. What are the possible choices one can make at a given time, given a whole set of notes that one can play, or when one can play that note. And I think that moment of not knowing, okay, but having an arsenal of things that you've worked on in the past, somehow my subconscious can access that. But also being aware and appreciative of that nature at some level also works that way. Gives me confidence sometimes. And, as Miles Davis said, someone said, Miles, that there's no such thing as a wrong note. It's how you play it.
Huh. Nicely
I don't want to misquote Miles. Maybe I said that.
Let me put one other thing that Jonah Lehrer said to us in the interview we just did, and then put it to you and see what your view is on this. He gave numerous examples in his book about creative breakthroughs that only took place because the people who were involved with them managed to somehow take an outsider's perspective on something. If you're too deep inside something, he said, in a way you can't see it because you're too deep inside it. You either need an outsider's perspective or you need to get away from it for a while. Do you share that view as well?
I absolutely agree with that. I got to buy that book. It sounds excellent because I absolutely agree with that. It's actually been the fuel of my career in physics. I've always been an outsider looking in. I've always, been, as we know, as you probably know, and the audience, the theoretical physics is very broad, and there are all these subdisciplines and specialties within the field. And for example, I'm not, my PhD was not in string theory, it was in cosmology, but I worked on string theory problems as an outsider looking in, and that gave me, because I had this, a dummy's mind basically, it gave me, I had a totally new way of looking at the problems and interpreting them and advancing towards solutions, and vice versa. So I'm always looking at other fields. Maybe I'm a bit of an interloper, but I try to be nice to people. And
Interlope away.
Right, there is territorialism and all these things going on, as with any field. So, but definitely, I've always worked on problems as an not always, but I enjoy doing that, and I highly recommend it.
Well, let me put another quote to you.
I also feel like that about jazz.
You feel that way about jazz.
Hello?
Let me put another quote to you. This again from Jonah Lehrer's book, where he says, "Because we live in a world of very hard problems, all the low-hanging fruit is gone. Many of the most important challenges exceed the capabilities of the individual imagination. As a result, we can find solutions only by working with other people. Does that attitude apply to theoretical physics as well?
I absolutely, I mean, I agree. I think it depends on your style and who you are. And I still think that there are low-hanging fruit. We just haven't looked, or maybe one is not looking directly at the fruit. So I still think there are low-hanging fruit, and I think that is connected to being an outsider looking in. But I do agree that a lot of the, I've certainly solved problems or worked on problems and come to some, to some solution to realize that it's already been done by usually some Russian physicists in the 50s. So I agree at one level, but I still do think that if you're an outsider looking in, you can find a jewel or a low-hanging fruit that people just overlooked. Now, going back to this, I highly, I think collaboration and working together, just having this, I forget the word, but like a collective, mind, so to speak, is much better than being locked in an office somewhere solving equations. I think those days are kind of over, or at least it's never really been the case for me. I love having soundboards and being a soundboard to other people. And I like also, I like teaching intro classes, for example, or just talking to anybody about a physics problem or about jazz music, because I find that I get really good questions or good insights that, when you're an expert, you tend to overlook. And I've gotten some great ideas just by talking to lay people, for example. So collaboration with others in your field, but also collaboration with non-specialists, I think we should have more of that.
Gotcha. Well, in our last couple of minutes here, since you and Jonah are on the same page on so many things, let me throw one more quote of his your way and get you to react to this one as well. This is on the issue of whether or not creativity is sort of magic because God touched you on the shoulder, or whether you can actually learn how to be creative. And here's the quote from his book. Creativity, he says, is not magic, and there's no such thing as a creative type. Creativity is not a trait that we inherit in our genes or a blessing bestowed by the angels. It's a skill. Anyone can learn to be creative and to get better at it. New research is shedding light on what allows people to develop world-changing products and to solve the toughest problems. A surprisingly concrete set of lessons has emerged about what creativity is and how to spark it in ourselves and our work. So the question, Stephon, can everybody be creative?
I think it's a human, it is a human trait. It's, I think, by being human, we're creative. And I do believe that you can hone that. I mean, part of, one of the things I have to do in my job, of course, is to train scientists, to train PhD students and postdocs. And one of the things that I always try to, bestow, to give them is a little bit of my, my approach my approach toward being creative. And I think that there's a way that one could pass those skills on. So any people out there who are thinking of applying to a PhD program or undergraduate, come to Dartmouth, and I would train you to be, I would teach you to be creative, a little bit more creative.
So anybody can be John Coltrane then, eh?
Yes and no. So I do believe that, there are, everyone can swing a baseball bat, but not,
not everyone's going to be Ted Williams.
Exactly. So I do think that there's an aptitude, given that everyone has creativity and can hone, and you can always become more creative. I do believe that there are elements in becoming more creative and developing your creativity. I do believe that, Richard Feynman is just Richard Feynman. He's a genius, and John Coltrane is John Coltrane. Ornette Coleman would just pick the horn up and just play it, right?
But do you make a distinction in creativity or genius? Do you make that distinction between, say, Albert Einstein, who's one kind of genius, and, say, the guy who invented masking tape, which is, I guess, a different kind of creativity? Do you make the distinction? Do I make the distinction? It's hard to make that distinction
because, you know, there are different things. But I would say Albert Einstein and myself. I mean, Albert Einstein is a genius and I'm not, right? We're both, I would like to think of myself as a creative person.
Yeah, I bet Einstein couldn't play the saxophone.
Leaps. He played the violin, but yeah, he should have played the sax though. Can you imagine seeing Einstein with a sax? That would have been really awesome.
That would be totally cool. Yeah.
Yes.
Stephon, you know what? That's our time tonight, and I want to thank you very much for giving so much of it to us here at TVO. We've thoroughly enjoyed talking to you about theoretical physics and being a jazz saxophonist and creativity. So thanks for joining us tonight from New York City.
Thank you so much, and I look forward to coming to some of your wonderful jazz clubs out there in Toronto, one of my favorite cities in the world.
We'd love to have you up there. Thank you very much.
Thank you.
Stephon Alexander.
Support Ontario's public television. Donate at tvo.org.